Hello, everyone. This lesson is going to be on writing equations of parabolas. Now that we've gone through a few days of learning how to graph them and all their characteristics, particularly the new characteristics, the focus and the directrix, now we're going to be given information and work it backwards so that we can write the equation of a parabola. So just quick little recap of a few things. The equation of a parabola in vertex form, that's the one we like to use the most. If it is vertical, it's always y equals a, that leading coefficient, multiplied by x minus h, quantity squared, plus k. Remember, the opposite of your h and your k value give you the vertex, and that leading coefficient helps you determine the focus and the directrix, as well as helps you plot points for graphing your parabola. And for the horizontal version, remember the y values are on the outside. For vertical, x's are on the inside of the parentheses. So we're going to flip those things. For horizontal in vertex form, it's x equals leading coefficient a is still the same. Now in our parentheses, y minus k, that quantity squared, plus h. So your vertex is still h comma k, but remember we're taking the opposite of the k value because that's what's in parentheses. When we're looking at parabolas in standard form, these are the ones that look like regular trinomials. So for vertical, always again, it's got to start with y equals, and this will be a x squared plus bx plus c. Remember, to get our vertex, we have to take the opposite of our b value, that linear term, bx, and divide it by 2 multiplied by our leading coefficient. That'll give us, in this case, the x-coordinate, or h, of your vertex, and then you'll substitute back in to get the y value or the k value. Another little bit of info that we learned or were reminded of is that the constant value is also, in this case, our y-intercept. So your graph should cross at that point, and you should make sure you include that one. For horizontals in standard form, again, it's horizontal, so the equation has to start with x equals, and it's going to look very similar, but all of our x's changed to y's now. A, y squared, plus by plus c. Again, to find one of the points of our vertex, we are going to use the opposite of the b value divided by 2 times a. That will give us the y coordinate or the k value for a horizontal parabola. You'll substitute back in to get the x coordinate. And in this case, that constant value, the c at the end, this should now be your x-intercept because it's horizontal, so it's sitting on its side. All right, that's our quick review of a couple of things we've done in the last few lessons. Let's move along to practice some of these. Our first one, I love when they give me a graph. It makes life so much easier. Oh my goodness, it's fabulous. So I first look at the graph that I'm given, and it is opening up. So that tells me that my a value has to be positive. That also tells me that it needs to be a vertical equation, so it has to be y equals. Okay, because it is graphed, I can very clearly look to see what the vertex is. So I know our vertex for this one is at the point 1, -4. So those would be my h and my k values. Okay, so writing in vertex form, pretty much have just about all I need. So it's y equals a, we'll get that in just a moment, multiplied by x minus the h, which is 1, quantity squared, and then plus k, in this case would be -4. Now again, looking at our graph, to get our leading coefficient, our a value, remember, we can use that a value just one time to plot the next set of points from the vertex. So I should be able to look from the vertex and count up, because it's opening upwards, and to the right and find the next best point. And I do in fact go up one to the right one and find the point 2, -3, as well as up one to the left one and find the point 0, -3. So that tells me that my a value equals 1. Now you can put that out in front of the parentheses of the x minus 1 quantity squared for your equation, or you can just leave it as that quantity, x minus 1 squared and then -4. So totes up to you for that. All right, finding the vertex and the directrix. So remember, we have to use our a value and set it equal to 1 over 4 multiplied by p. If I know that leading coefficient is 1, I'm going to say 1 equals 1 over 4p, and then we'll cross multiply. So I'll get 4p to equal 1, and my p value is 1/4. Remember, this is the distance that you travel from the vertex. And in order to get the focus, remember my focal point has to be above my graph. I'm going to erase a teeny bit for that slope part that I was doing right there. So my focus has to be inside the parabola, and in this case above. So 1/4 above the vertex. So I'm going to add 1/4 to the y value, which means -4 plus 1/4 gives me -3 and 1/4. Okay, your focus has to be a focal point, and it's always inside. Sometimes you'll move up, sometimes down, sometimes left, sometimes right. But you'll notice what's changing because it's vertical. My focus point, only the y part changes. Okay, and then when we graph our directrix, that moves 1/4 of a distance, but in this case below. Make sure you draw that horizontal line below your parabola. So I need to go down, so I'm going to subtract 1/4 from the y value of the vertex. So -4 minus 1/4 is -4 and 1/4. And that does need to be an equation. It is a line. It's cutting through the y-axis, so it's y equals -4 and 1/4. Okay, so a couple of things to remember we've talked about. If it is a vertical parabola, all of the y values for your focus and directrix will change. You'll notice that the x values for vertex and focus stayed the same, and for our axis of symmetry, it didn't ask, but our axis of symmetry would be x equals 1. We would have that dotted line cutting our graph in half. Okay, there's our first example. Let's move along. Right, our next one, we're doing the exact same stuff. So let's, given a graph, this is pretty nice, we can find the vertex and we can look at the direction that it opens. So in this case, my graph is opening to the right. That means that my a value is definitely positive. And because it opens to the right, it has to be an x equals equation. So I've already got the vertex. I'm going to go ahead and fill stuff in. We'll get that a value in just a moment. So it's x equals a, your leading coefficient, multiplied by y minus your k value, that quantity squared, and then plus h. Remember, x equals has all the x stuff on the outside. Our vertex is the point 1, 2, 3. Let's see, -3, +1. So my y value goes in the parentheses, so it's y minus 1, that quantity squared. My h coordinate goes on the outside, so -3. And now we do have a really good point that we can use. So in this case, remember, it's sitting on its side. So you can think rise over run if you tilt your head kind of sideways and look at it. And I go, oh, I go to the right a couple and then up and down one. So I'm traveling 1, 2 to the right and up 1 to get a point, and right 2 and down 1 to get a point. So that means that my a value, that distance that I've traveled for the leading coefficient, is +2. Okay, so our equation is x equals 2 multiplied by the quantity y minus 1 squared minus 3. Okay, going back to get our focus and directrix, we are again going to take that leading coefficient of 2, set it equal to 1 over 4p. We'll cross multiply to get 8p equaling 1, and our p value equals 1/8. So again, from the vertex, I need to move a distance of 1/8 to the right and to the left so that I can get focus and directrix. Remember, focus is inside, so I need to move to the right 1/8. And again, guys, we're just estimating where that point is. You just gotta know It's in a teeny bit from your vertex. So since I went to the right, I need to take the x coordinate and add 1/8 to it to move myself to the right. So that becomes a value of -2 7/8 for the x coordinate, but you'll recognize that the y coordinate stays the same. Okay, and then I'm going to move that exact same distance, but to get my line for the directrix on the outside, I'm going to move to the left. So if I move to the left 1/8 from the vertex and draw that vertical line, that is cutting through the x-axis, so it has to be an x equals equation. And I'm going to take the x coordinate -3 and subtract 1/8 because I moved to the left. So that would give me -3 and 1/8 equals x for the equation of the directrix. Okay, so we've had one vertical, one horizontal. Given the graph, makes life so much easier. From that point, we were able to create the equation as well as find the focus and the directrix. The directions also said to convert it into standard form. I'm just going to do that in some of the other problems. I don't want to do that for every single one. It's a little bit time consuming. We're going to be working more from standard form back into vertex. Our next example says, given the focus and the directrix, write the equation of the parabola in vertex form, convert to standard form, and that a sketch might help you. I'm very visual. I got to draw myself a picture. I need to see where things are and what they mean and represent to help me get this equation. All right, so we are given that the focus is the point 1, 4. So I'm just going to go ahead and roughly sketch the point 1, 4. There's my focus. Put a little F there. And that my directrix is at x equals -4, so I need to go to -4 on the x-axis and draw a vertical line, x equals -4. There we go. Okay, so based upon the things that I have, first off, I was kind of tipped off by the directrix. Hopefully you kind of make connections with the equation of the directrix and the equation of your function. But based upon the placement of the focus in the directrix, I have an idea now that my function has got to open to the right. And you see that I draw a dotted curve because I don't know exactly where any of the placement is for the vertex or the actual leading coefficient, you know, how skinny or wide this graph needs to be. But if the focus has to be inside the parabola and the directrix has to be outside the parabola, then my vertex has got to be right smack dab in the middle of those guys, and it needs to open to the right so that I can include that focus on the interior of the parabola. Well, if it opens to the right, I know two things. One, my A value has to be positive. And two, more importantly, the equation is going to be x equals. So I'm going to go ahead and start my equation, x equals a, leave a space for it, parentheses y minus k, leave a space for it, squared, and then plus h. So we're looking for leading coefficient and the vertex h comma k. All right. Another thing that, a couple of other things that I know are that the focus and the focal point, the x value is what's going to change to get me my vertex. So my y value of the focus is going to remain +4. Okay, another way you can prove that to yourself is, okay, where's the axis of symmetry going to land? It doesn't ask us for it, but that's another visual thing that can help us. So if my axis of symmetry has to go through the vertex and through the focus, then I can draw that horizontal line, y equals, through that focus at y equaling 4. So I've got all my y values from focus, vertex, and axis of symmetry remaining the same. It's the x's that are changing for this particular function. Okay, next thing is, how are we going to figure out what's the exact x value or h coordinate of our vertex? So think about how things are placed. If I'm starting at -4 on the x-axis and I'm traveling over to the focus at +1, the distance between these 2 points is 5 units. And the vertex has to be in the middle So if I take 5 and divide it by 2, same thing as 2.5, 2.5, that tells me how far I need to travel from the focus going to the left 2.5 units, and from the directrix going to the right 2.5 units. That's going to tell me exactly where my x-coordinate of my vertex lies. So if I go from 1 back 2.5 units, I'm at -1.5. If I go from 4 to the right 2.5 units, I'm still at -1.5. So you can write it as -1.5 or -3/2. That's where my vertex lies. Okay, so now we have everything for the vertex. Now, we haven't done any fractions for vertices, or not very many, I should say, but that's okay, not a problem. You just pop them in like normal. So x equals a, still don't know that yet, y minus k, quantity squared, so y minus 4, and then plus my h value, in this case is -1.5 or -3/2 on the back side. Okay, our last piece is to find that leading coefficient. If I know what we've used is that a equals 1/4p, okay, and we've used it backwards, we've known that leading coefficient. Well, now we actually know what the distance is. So I know that my distance from the vertex to focus and from the vertex to the directrix is 2.5 or 1.5. So, or excuse me, 2.5, not 1.5, 2.5. I can go ahead and substitute that as my p-value. That's the distance traveled. So a is going to be 1/4 multiplied by 5/2. 4 times 5 is 20. 20 divided by 2 is 10. So a is 1/10. And you just put a 1/10 in the very front of your equation. All right, now that takes a little bit of work. It takes some practice. So don't be troubled by it. Just take it piece by piece. Sketch what you know, find your distances, find that p-value, use it to help you get coordinates of the vertex, and then plop it all back into vertex form. Okay, good job, guys. Let's try another one. All right, example 4. This time we are given the vertex. Oh, we made it so easy on ourselves, and the directrix. Okay, so again, think about things that you're given. My directrix, that's my line, is at y equals 9. So I'm going to go all the way up to 9 and sketch that line on my y-axis. And I also know that I have the vertex at the point 2, 5. So to the right 2 and up 5. There's that guy right there. Okay, so we're missing the focus, that's our question mark, and we also need vertex form. All right, now this one's going to be a little bit easier because we already have the vertex. Check, there's our h and our k values, piece of cake. All right, so think about which direction is this function going to be opening? Is it going to open up or down, left or right? Okay, so think about the placement of your directrix. It is above the vertex, so that means my focus has to be below, somewhere over here. We'll put it there exactly where it goes in just a moment, which means in this case that our graph, and again, this is total rough sketch, we'll put in the real sketch later, focus is below, so our graph is going to open down. If my graph opens down, that means my a value has to be negative, and my equation has to be a y equals. And that was also kind of given to you right here. The directrix is y equals, so your equation should be y equals. So I'm going to go ahead and fill in the stuff that I know. Y equals a negative, whatever the a value is, and then in the parentheses, x minus h, so x minus 2, quantity squared, plus my k value, which is 5. Okay, so we have the majority of the equation. Fabulous. Okay, in this case, because we were given the vertex and the directrix, I can just find that distance. So to go from the vertex up, I have to move up 4 units. So that means my p-value is 4. That distance is 4. So to get the focus, I got to do just the opposite. The focus is going to be, oopsie, I should put that in a different color. The focus is going to be down 4 units, which means from the point 2, 5, I'm going to go down 4, 1, 2, 3, 4, and my focus is actually at the point 2, comma 1. Now remember guys, this is a y equals equation. All of the y values are changing. The x's are staying the same. If I were to draw my axis of symmetry, it doesn't ask, but my AOS would cut through at x equaling positive 2. Okay, that would still be there. All right, now that we know what our p-value is, we can work backwards to get the a. That leading coefficient, a is 1 over 4p. And our p-value, the distance we traveled, is 2. So 1 over 4 times 2 gives me 1/8. So I know that the p-value is 1/8. That goes in the very front as my leading coefficient. Again, make sure that you have that negative sign there because the graph does open down. So our equation for this function is y equals negative 1/8 multiplied by the quantity of x minus 2 squared plus 5. Good job. All right, another example, given the vertex and that p equals 4, write the equation of the parabola in vertex form and then convert it to standard. Okay, we're given the vertex again. We're given the p-value, so we're going to do the extra step for this one, and we're going to convert it into standard form after we put it into vertex form. And it says you get to choose if you want it to be vertical or horizontal. So I'm going to go vertical on this guy, and the next one I'll choose horizontal to make sure we get one of each. So if I choose vertical, the equation has to be y equals a multiplied by the quantity x minus h squared plus k. The things that you can go ahead and pop in are the vertex and the x's and the y's. So y equals, leave a blank for the a, x minus negative 1 becomes x plus 1 squared, and then our k value is plus 3. Okay, check, took care of that guy. If I know the p-value that was given to me, that p equals 4, remember we can work it backwards. Use our leading coefficient, a equals 1 over 4 times p. So a equals 1 over 4 multiplied by 4, or 1/16. So my a value is 1/16. So our equation, y equals 1/16 multiplied by x plus 1 quantity squared plus 3. Okay. We also do get to choose if this is opening up or opening down. Most of us are going to choose open up, but I want to practice opening down. Of course I would, right? So I'm going to go ahead and make my a value negative just to practice. So that means just a rough sketch. If it's opening down, here's my focus on the inside, there's my vertex, and there's my directrix above. I know that the p value, I have a distance of 4. So from the vertex, I need to go up 4. So 3 plus 4 gives me 7. So the equation of that line would be y equals 7. And that's to get the directrix. I'll also need to travel down 4 to be on the interior of the function. So I'll have to go and take 4 away from that y coordinate to give me, so 3 minus 4 would give me negative 1. So the focus is going to land at the point negative 1, negative 1. If I had chosen to open it up, the y values for focus and directrix would have just changed places. Same numbers, just been different places. Okay. And now here's the part to putting it back into standard form. It's going to be a little ugly, just stick with me, but we just need to practice at least one of these guys. So the first thing that we have to do with our equation, y equals negative 1/16, is we need to multiply that quantity x plus 3, or excuse me, x plus 1, whoopsies, x plus 1 squared. I got to do that guy first. That is a perfect square. Same thing multiplied by itself. So it's going to give me x squared plus 2x plus 1. That's all multiplied by negative 1/16. And then I have plus 3 at the tail end of it. I need to now distribute that leading coefficient. Y is negative 1/16 x squared. 1/16 times 2 would give me 2/16. So that's minus 1/8 x minus 1/16, and then plus 3. Last little chunk, add those two constant values to get our equation into standard form completely. Y is negative 1/16 x squared minus 1/8 x plus 2 and 15/16. There you go. That is standard form. So again, in standard form, you're going to square the part that is squared, distribute the leading coefficient, your a value, and then add the constant at the back end. And we had our vertex form up here at the top. Great job. We have one more. This one is going to be to write the equation in vertex form, convert to standard. We will try it. This time we're given our a value and the vertex. Choose horizontal or vertical. We are going to choose horizontal, and we're going to go ahead and make this guy go to the right because we did down and vertical last time. So we're going to do right and horizontal this time. Okay. So in vertex form, if it's horizontal, it has to be an x equals. I know my a value. Thank goodness they already told me. A is 8. I know the vertex, x minus, oopsie, look at that. I made a mistake, excuse me. That needs to be y minus, goodness. Y minus the k value, so minus -1 gives me plus 1, quantity squared, and then plus the h value on the outside, plus 2. Cool, got that down pat. That's great. Love this. Let's go ahead and convert it into standard form since we have the entire equation. That was a piece of cake. So that guy is vertex. We'll come back and get focus and directrix in just a smidge. That won't take us too long. So x is going to equal 8 multiplied by y plus 1 quantity squared. So that'll be y squared plus 2y plus 1 and then plus 2. Again, distribute the 8, so that'll be 8y squared plus 16y plus 8 plus 2, and then combine like terms. So in standard form, the equation of this one is x equals 8y squared plus 16y plus 10. Fabulous. Great job. Standard form. Yay! That wasn't too bad. The last one wasn't even that bad. Just had that fraction. Okay, so now let's go back and get our focus and directrix because those are the other things that it needs for us to do. Continue that practice. So we know our graph is opening to the right. We know the focus has to be inside and it has to move that distance of p to the right from the vertex, and our directrix has to be on the outside. That line will have to be to the left of our vertex. So our y values for the function are going to stay the same. So I already know the back end of the focus has to be -1, and that acts as a symmetry would also be y equals -1. So each of those y values remain the same for these functions. It's the x's that have to change. So how far am I traveling? The distance from vertex to focus and from vertex to directrix. Alrighty, so take your a value, set it equal to 1 over 4p, cross multiply to get 32p equaling 1, and then divide through and we get 1/32. We are barely moving at all. The distance from the vertex to the focus is 1/32. I need to add it to the x coordinate, so that will be 2 and 1/32 for the focus, and I need to subtract it from the x coordinate to get the equation of the directrix, which has to be x equals. I have an x equals equation, so I have to have an x equals directrix, and 2 minus 1/32 would give me 1 and 31/32. Not a great number, but hey, it works. Okay, great job, guys. We've gone from graphs to equations. We've been given a vertex and another value, the a, the p value, or possibly a directrix or directrix or focus, as well as a focus and a directrix, practicing both vertical and horizontal for each of these. There are plenty more for you to practice on the following worksheet in your packet. Make sure you are practicing these. They don't come like lightly. You got to practice some. Hope you guys have a great day, and we'll talk to you later.